All right, can you tell what type of function we're dealing with? Up until now, we've been given several scenarios. Well, in this video, you're going to see several different scenarios. We've talked about three types of functions. We talked about linear, quadratic, and exponential functions. All three of those, we have seen equations, tables, and graphs. So what it's going to do is it's going to give us a scenario, and then we have to decide, is it linear, exponential, or quadratic? What type of growth it is, and we have to give a different representation. This first one here, we haven't seen a whole lot of word problems, all right? But the first one isn't that complex, right? The example he gave in class was, hey, all of you own a home. I'm a plumber. I come and knock on your door. Knock, knock, knock. You say hello. Just because you answered the door, you owe me $55. I haven't done anything yet. You're like, well, but wait a second. No, not wait a second. You called me, the van, my equipment, everything, gas to their time costs me money. So in certain industries, they will have a base fee, okay, which is what they call for a service call. That service call is $55. So if we look at it as like total amount, my total for the cost of the job is going to be $55 plus something. Well, what is that plus something? Because if I read the question, it says plus $35 an hour for each hour that we're called. What type of relationship is that? Well, remember, it's $35 per hour. So it's $35. And how do I calculate the hours? Well, gee, if I work 1 hour, it's $35. If I work 2 hours, if I work 3 hours, how much is that going to be? This is where my variation is going to take place, because it could be 1 hour, 2 hours, 3 hours, 4 hours. So I'm going to make that H. H for hours. All right, well, if I work 2 hours, I tell you it's going to take me 2 hours. How much is that going to cost? Well, 2 times 35 is 70 plus 55. That total is going to be $125. If I work 3 hours, it's going to be 125 plus 35 more than that. So you should begin to see what's going on here. If I work 1 hour, it's 35. Excuse me. If I work 2 hours, how much money am I going to charge you for that second hour? If I work 3 hours, how much is that third hour? This is a linear pattern because it's 35 plus 35 plus 35 plus 35 plus 35. The 55 is just what it cost me to get there. The growth for this is constantly increasing because the more hours I work, the more money it's costing. What is the rate of change? The rate of change of a linear function is constant. And down here at the bottom, remember, we talk about equations, tables, and graphs. That's how we describe these three functions. Well, give me a different representation than this wordage right here. We pretty much have come up with that. If you're paying attention, here is my focus right here. Y, or f of x, equals 55 plus 3h, where, excuse me, not 3h, 35h. Where h is the number of hours, y is going to be my output. You could put f of x, right? So there's number one. We'll do one other one, and you should kind of get the idea from here. Well, what do they give me? They give me a graph. So the other two different representations that I'm going to come up with is going to be a table or an equation. That's the other two I'm going to come up with. This, you better tell me it's quadratic. Why? Because it's a parabola. What growth is happening? The growth that is happening is both increasing and decreasing in this particular case. The rate of change of a quadratic function is not constant because that was linear. It's not exponential because the rate of change of an exponential function is exponential, so it has to be linear. Remember, the only thing I can do is determine between 2 points what is the rate of change on a curve. That's rise over run, that's slope. That's the best I can do. That's the reason why the rate of change of a quadratic function is linear. All right? Now, what about my different representation? We have not talked about creating an equation from a graph yet. We will get there in Module 2, but we haven't. So the other alternative is a table. So how is that table going to look? Well, from tables, if we go back and look at all the way back to like 1.1, 1.2, if you look at tables, how do we determine if they're quadratic? Well, one way is second differences. But if we look at the output values, what we should notice, those output values should increase, they should get to a maximum point, and then they should decrease. So this maximum point right here, 0 and 5, I'm going to put in the middle of my table. Remember, those outputs should increase, get to a maximum, and then they should decrease. Where am I going to pick these other points from? I need an equation. No, you don't. You have a graph. Pick your points from your graph. Take the points out of the graph and put them in your table. I'm going to pick nice, good points. I'm going to pick this one here, which is -2 and +1. I'm going to pick this other one over here, which is -1 and 4. I already have 0 and 5. After 0 comes 1 and 2. Remember, they increase and they decrease. But how should they decrease? Parabolas are symmetrical. So 1, 4, 5, 4, and 1. If you don't believe me, look at 1, it's at 4. Look at 2, it's at 1. There's your difference. Right? So that kind of gives you an idea of how we do this. So look at 3, be careful with number 4, right? And then look at 5 and 6. You should be able to work on those. If you have questions on that after those, please ask, okay?